The last type is going to be where there's logs on both sides. Now technically these problems can be done just like the ones that we did previously. You would just subtract this other logarithm over and then combine it. But because I have log equals log, what that's going to let me do is simplify the logarithms. So first I still want to combine. All right, so if I combine, I've got a sum of logs on one side. That means I have a log of product. So log base 5 of x plus 2 times x equals log base 5 of 2. And because I know that the log function is 1-to-1, meaning whatever this thing is, whatever number this is, it has to be, whatever number's inside my logarithm, it has to be the same as this one. So there's a lot of different steps you can think of for doing this. I can just, so as before, base to the power equals argument. So base here is 5 to the power, that's what the log is spitting out, so 5 to the log base 5 of 2 equals x plus 2 times x. But this log base 5 to the log base 5 of 2, this log says whatever I am, raise 5 to this power and you get 2. So if you raise 5 to that power, what do you get? 2. So this is equivalent to equating the arguments in the logarithm in this step. So from here to here, I just equated the argument, and I was allowed to do that because I have log equals log. If I have anything outside of the logarithms at all, I'm not allowed to do that. But in this case, I was. So this thing is going to be quadratic. So we're going to set it to 0 and solve. So x squared plus 2x, so that's multiplying, and then subtract 2. Factor, is it factorable? I don't think so. Right? So we need to try and use the quadratic formula for this. So what is the quadratic formula? It's negative b plus or minus square root of b squared minus 4ac all over 2a. So negative 2 plus or minus square root of 4 minus 4 times 1 times negative 2 all over 2. And I'm going to skip a little bit of the simplifying step just to save a little bit of time. Oh, here we go. So 4 plus 8 is 12, so 2 root 3. Two square root of 3 all over 2, which is negative 1 plus or minus root 3. Okay, so there's two possible solutions. One of them is negative 1 plus root 3, and the other is negative 1 minus root 3. Now, square root of 3 is bigger than 1, right? So if you have negative 1 plus something more than 1, it's positive. If you plug a positive thing and add to it, it's still positive. So in both, plugging into both of these, it's okay. Negative 1 minus something is going to be more negative, so if I plugged it into log base 5 of x, I can't have the negative there. So I'm only going to be able to have one of the solutions. So negative 1 plus root 3 plus 2 is greater than 0, and negative 1 plus root 3 is greater than 0. So plugging one of the solutions into either one of these logs, both of these logs I should say, works. But negative 1 minus square root of 3 is not bigger than 0, so I can't have that as a solution. So my only solution is -1 plus the square root of 3. That's my exact. My approximate, they ask for 4 decimals. So -1 plus the square root of 3, which is 0.7321. All right, so that's my solution. So I did the exact same thing as in all the previous ones. I rewrote it as an exponential. But because there was a log on the other side where my power was, the 5 and log base 5 cancel to just give me the 2. So then I end up with something quadratic. In this case, the quadratic wasn't factorable, so I had to use the quadratic formula. This obviously comes from your homework. You guys know that I just pull up the homework and like click through the problems until I see ones that I think we should do. This one is in the homework, so you will have to do the quadratic formula on it. I don't remember if they ask for an exact solution, but I'll be checking your exact solutions on exams. But they definitely are going to ask for the approximate. So once I use the quadratic formula and simplify it, I plug it back in. I have to make sure that whatever's in my log is always positive. So the fact that one of them was negative, because it's a negative minus something, automatically means no good, can't use that one. All right, one last one. I know we did a lot of examples of the logarithms, but there was 3 kind of types, and this way we did 2 of each type. All right, this one is the natural log of x plus 1 plus the natural log of x minus 4 equals the natural log of x plus 5. So first combine these. So sum of logs is log of product. And I know that I can equate the arguments here. So I don't need the logarithms anymore. Because what's going to happen is I raise my base, which in this case is e. So I raise e to this power, natural log of x plus 5 equals this stuff, but e to a natural log means those cancel and I just have x plus 5. Okay. So this is quadratic. So I have x squared minus 3x minus 4 equals x plus 5. Which means x squared minus 4x minus 9 equals 0. This is another not factorable one. All right, so x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So 4 plus or minus square root of negative 4 squared is 16, minus 4 times a, which is 1, c is negative 9, so that's plus 36, all over 2. So 16 plus 36 is 52. right. So 52 has a factor of 4 to pull out, which gives me 2 root 13 over 2, or 2 plus or minus square root of 13. Okay, so I get this, 2 plus or minus root 13. 2 is, so square root of 13. What would the square root of 13 be? Well, 3 squared is 9 and 4 squared is 16. So this has to be like 3.5 squared. Okay, good. Good. So if I have two solutions, right? I have to plug both of them into all of my logarithms. So the x plus 1, x minus 4, x plus 5. This thing plus 1 is bigger than 0. The minus 4, so 2 plus 3 would be 5, minus 4 would be positive. So since root 13 is bigger than 3, this is also positive. And 2 plus the square root of 13 plus 5 is also positive. So 2 plus root 13 works. The other one, 2 minus root 13. So root 13 is bigger than 3. So this thing by itself is already negative. So if I subtract 4, that's even more negative. So that's not positive. So I cannot use 2 minus root 13. So my only solution is going to be 2 plus the square root of 13. That's my exact. And for my approximate, I get 5.6056 because they wanted 4 decimals. So 5.6056. And isn't that what I said? I said that root 13 was like a little bit bigger than 3, maybe 3.5. All right, so 2 plus 3.5 would be 5.5, which is about what we got. Okay. Solution. Now, I am not sure on Hawks whether all of them that are of this type use the quadratic formula. It might just be coincidence that the 2 I picked did that. I didn't solve these ahead of time, of course, because I like to talk through it as I'm doing it so you guys can see what I'm thinking. It may be coincidence, it may not. Even if you didn't use the quadratic formula on this, like the steps are still the same. Combine, rewrite, quadratic, or maybe linear, and simplify. Always make sure that you check at the very end.